Good afternoon, good evening, and welcome to this webinar on how to ace GMAT Algebra. My name is Rajat Sidana. I'm one of the co-founders of e-GMAT, and I'm going to be your main host today. Supporting me in this webinar, we have Ashutosh Mishra. Ashutosh is a GMAT Quant expert as well as a GMAT strategy expert at e-GMAT, and he's going to be a co-host today. In this webinar, we're going to look at how, if you have a basic foundation in GMAT algebra, using a simplified method, you can solve 600 level as well as 700 level questions. Fairly application focused webinar. We want to make sure that and just to really be able to solve all these questions, all you need to know are some fundamental principles in inequalities and absolute value. And to make sure that you have those principles, we did send a few video lessons your way. The video lessons on the left hand side are the ones that we sent your way. If you have not gone through these video lessons, you can always get them as a part of the e-GMAT free trial. Just log into the free trial and you should be able to get to them. I'm going to actually minimize this pane. We also have some upcoming free sessions. We have a free session on how to score 760 on the GMAT. That one's tomorrow. That one's next Saturday at 7 in Pacific time. And then we have a free quant workshop. So the free GMAT strategy webinar, think of it as a webinar if you are aiming for that score of 760 or higher, or actually even 730 or higher. It'll help you create a personalized study plan. It'll tell you how to execute on that study plan, and then what metrics to track as you proceed during your study. Let's kind of get to know a bit more about you. So what's your target GMAT score? Let's kind of get the data over here. And while we get that data, I'm going to tell you about the quant workshop. The quant workshop is, think of it as a proctored mock test, but a mock test that gives you insights not just about where you currently stand, but it also tells you which are the areas that you need to work on. So think of it as a mock plus in many ways. It will also tell you what kind of habits are preventing you from getting to that Q49, Q50, or Q51 score. All right, we do have the data over here right now. I have about 72 students, and based on the data over here, what I can see is that a good chunk of you, about 40% of you, are in that 730 to 750 bracket. About 16% of you are in that 760 or higher bracket. A good number of you are in that 710, 720, and then about 20% of you are in that 600 to 700 bracket. All right. With regards to when you plan to take the GMAT, we have a fairly uniform split. The smallest group over here is about 13%. The largest is about 26%. So we have enough people in each and every segment over here. With that, let me go right into the presentation pane. And as I go into this pane, what you're going to really see is the screen will change for you. You're going to see a presentation pod in about another 10 seconds or so. And in addition to that, you will also see a Q&A pod. So during this webinar, if you have any question, you can put that question in the Q&A pod, and Ashutosh would be happy to answer that question. With that, let's go right into the webinar, and I want to start right from here, which is the core of this webinar. So this webinar is going to be about 2 hours from this point on. So if you are in the US, it'll be till 9 a.m. Pacific time. It'll be till noon Eastern time. If you are in India, it'll be till 10:30 p.m. IST. So what's the purpose of this session? The primary purpose of this session is to make sure that we tell you how to apply the concepts that are tested in inequalities and absolute value. We do expect a certain foundation, but a very bare minimum foundation. And as we teach you how to apply these concepts, we want to focus on a unified process to solving those questions. We want to focus on making sure that you understand why you make mistakes, where you make mistakes, and give you feedback as to how and which areas to focus on so that you don't make careless mistakes or mistakes which are not what we call as truly subject matter based mistakes, but mistakes because of bad habits. So we want to identify those mistakes. We want to make sure we don't repeat those mistakes. And for most of you, if you have that bare minimum foundation, by the end of this webinar, you're going to find that A, you're more aware of why you make a mistake and where you make a mistake. B, that you're going to probably say that it's not because I don't know the math, it's because I don't have the right habits. And C, you would really say this is what I'm going to focus on as I solve more and more questions of this kind. So, in terms of the progression of this session, we're going to cover the following concepts in this webinar. We're going to cover linear inequalities, quadratic inequalities, absolute value, and equations as well as inequalities. We'll have a fairly basic warm-up quiz. This is what I call as, think of them as 500 level questions. And then all of these questions are going to be problem-solving questions. Then we're going to go towards 600 and then 700 level questions overall. The idea really is just, if not brush your concepts up, these basic concepts this warm-up quiz will help brush those concepts up. And then as you go into 600 and 700 level questions, you're going to be able to apply those concepts. And then you get some questions, you won't get others. And you'll be able to really see why and where you make mistakes. Okay, so with that, let's go right into the warm-up section. I want to make sure that you have a pen and paper ready. I want to make sure that you have a bottle of water ready with you, because it's going to be a 2-hour marathon in which we're going to solve a bunch of questions. All right, so here's the first warm-up question. I'm going to move this over here, and here is a poll. All right, we have most of the answers. Let's get a few more, and then we're going to move on to the next warm-up question. Three, 2, and 1. Here's the second poll, and here's your second question. Let's get a few more responses. You have last 10 seconds. 5, 4, 3, 2, and 1. Let me end this poll, and I'm going to reopen. I'm going to give you the third poll over here. Just 1 second. Here's your third poll. I'm going to show the third question over here. Remember, the poll has 5 options. There are only 4 choices. Please ignore option E. Guys, another 30 seconds. Let's get these answers in. Five, 4, 3, 2, and 1. Let's end the poll. All right, so each of these 3 questions, foundational questions, warm-up questions, or what I call as 500 level questions, each of these questions tests the same basic concepts, but the accuracy levels across them are very different. What happens, what we've done is we've used the same basic concept. We've actually increased the complexity, not from a math standpoint, but from but just from the ability to solve standpoint. So it's the same concept. It's the same method. The first one, pretty much everyone got it right. 88% of you chose choice B, which is the correct answer. Okay, so the question simply says, hey, what is the range of values of y for this inequality? And essentially what you do is you actually move minus y to the left hand side, or you can say you add plus y to both sides, and the inequality simply becomes 5y is greater than 10, which means y is greater than minus 2. Essentially it's solving an inequality, and pretty much all of you did it. If you did not do it, if you made a mistake, you've got to really look at why you made a mistake, and if you continue to make mistakes in warm-up quizzes, then essentially I'd recommend you go back to the free trial, solve the free concepts, build that foundation, and then you can watch the recording of this webinar. Now let's look at question number 2. Question number 2, again, a majority did really well, but 72% of you answered it correctly. That's question number 2. But again, the fundamental principle over here, a very basic knowledge of inequalities was required in this particular question. In the second question, we actually took it a step further. We gave you two inequalities, and you had to really find the range of values of y for which satisfied both of these inequalities. Again, the process is very, very similar. What you do is you essentially take the first inequality, which is, let me actually draw this over here, which is x plus y. My bad. Give me 1 second. Let's try and use a different annotation. Take the first inequality over here and you multiply it by 2 and you get 2x minus 2y is greater than minus 6. So you have plus 2x over here and you have minus 2x over here, and you simply add these two inequalities and you do that, 2x and minus 2x get cancelled and you're left with y is greater than minus 2, which is your answer over here. Again, 72% of you got it right. It's a third question where I really see a lot of people making mistakes. Let's look at the third question over here. But before we do that, what did we test in this? You should be comfortable in solving two inequalities, and you should know that inequalities with the same sign can be added together. The third question, again, built on the same foundation. In fact, it was easier to solve. You again had two inequalities. The second part of this inequality is similar, not identical, but similar to the second inequality. Minus n and n cancel very neatly. Now, let me ask this. What does this question ask? What's tested in this question? What is tested in this question? Can you put your answer in the short answer poll? Integral values, non-negative integral values of m. Yes, non-negative integral values of m. And that's really important. And let's kind of really see this, because solving this inequality wasn't as difficult. You simply had to add both inequalities and you would get minus 4m is greater than minus 10. How many of you were able to get to this step? Let me actually put in a yes no poll. How many of you were able to get till this point? All right, how many of you were able to get to minus 4m is greater than minus 10? But half of you, okay. Then what you do is you multiply both sides by minus 1. When you multiply both sides by minus 1, is that correct? Absolutely not. Why? Because when we multiply an inequality by a negative number, you've got to change its sign. So it becomes 4m is less than 10. This is what it becomes, which means when you divide both sides by 4, or plus 4 to be more specific, you get m less than 10 by 4, which means that how many non-negative integral values of m does this satisfy for? Sorry, why? I have to just look at why is it that my shading is red. How many non-negative integral values does it satisfy for? It satisfies for 3 non-negative integral values, which is m is equal to 0, 1, and 2. Okay. Now, if you chose 2, and many of you chose 2, about 27% of you chose 2, you did not include 0. If you chose 1, you have to tell me why did you choose 1 for those of you who chose 1. So for those of you who made a mistake in this one, where did you guys make a mistake? For those of you who made a mistake in this one, and many of you did, where did you make a mistake? Did not notice it asked for non-negative, forgot for about 0. And again, that's where it's not about the math, it's about reading the question carefully over here. How is 0 satisfying? Is 0 non-negative? SP, is 0 non-negative? Yes, no. Okay. Is it integral? Yes. So it is non-negative and integral. Okay. All right. With that, let's go to our warm-up question 4. I'm going to put in your poll over here. Here is the poll. And the question asks, what's the range of x for which this inequality is satisfied? Right, I have a good number of responses. I'm going to give you another 15 seconds. Five, 4, 3, 2, and 1. All right, let me end the poll, broadcast the results. But 75% of you got it right. That's really good. Let's solve another question of this kind. I'm going to reopen the poll. Here's the next poll. I'm going to show the next question to you. All right, let's get those answers in another 10 seconds. 5, 4, 3, 2, and 1. Let me end the poll. I'm going to broadcast the results. But half of you got it right, the other half did not. Let's kind of look at this. So for those of you who've joined in the last 5 to 7 minutes, we're doing a few warm-up questions, fairly easy questions. And these are questions we expect you to know, so I'm not going through the explanation in as much detail. Once we get through warm-up questions, we still have one more warm-up question. We're going to look at 600 level questions, and which is where I'm going to go through the explanation in more and more detail. So let's go with warm-up question number 4. But 71% of you got it right now, exactly 71%. What this question asked was, what is the range of x for the inequality x minus 2 multiplied by x minus 3 to be greater than 0. So it's a product of two numbers, and we really are asking when is this inequality positive or greater than 0. And there are two conditions in which an inequality can be positive. When there are two conditions under which a product of two numbers can be positive. A, when both the numbers are greater than 0, or B, when both the numbers are less than 0. Okay, so let's kind of look at this. When are both the numbers greater than 0? When both x minus 2 is greater than 0 and x minus 3 is greater than 0, which means that if you look at the most stringent constraint, that x has to be greater than 3. So for x minus 2 to be greater than 0, x has to be greater than 2. For x minus 3 to be greater than 0, x has to be greater than 3. The most stringent one, x has to be greater than 3. Okay, now same way this way. They're positive when both x minus 2 and x minus 3 are negative. And when are both of them negative? When x is less than minus 3. Or x is less than 2. I'm sorry. So essentially, when you look at the solution, the two solutions are that x is either between 2 and minus infinity, or between 3 and infinity. So, and which makes choice C the correct answer. About 71% of you got it right, which means you have the basic foundation to get this right. Now, for those of you who made a mistake in this particular question, where did you make a mistake, or why did you make a mistake? Sorry, wrong poll. So why did you make a mistake over here? Yes. Now you can put in your answers. For those of you who made a mistake, why and where did you make a mistake? Let's get a few responses. Okay, forgot about the two negatives. What else? And are you writing this down? Did not check the complete case, did not consider the negative case. All right. Okay, it's really important when you make a mistake, you write it down, because we're going to look at how we test the same concepts again and again and again. So the two concepts that are tested in this particular question is just the basic conceptual knowledge of how to get to the correct answer, and the fact that, hey, a product of two positive numbers is a positive number, product of two negative numbers is a positive number. You just had to remember both those cases. The next one is where many more of you made a mistake. And the next one, but half of you got it right, the other half did not. Actually, I'm not going to go through the wavy line. So this was a more interesting question. You had a fraction. Fractions are usually a bit more difficult, and one of the most tempting things is to really say, hey, let me multiply both sides by x plus 4. Now, you can't do that. Why? Because x plus 4 can be both positive or negative, and if it's positive, we can do it, but if it's negative, we've got to really change the sign of the inequality, and since we don't know whether x plus 4 is positive or negative, we can't just multiply it by x plus 4. But what can we do to remove the denominator? We can actually multiply by x plus 4 whole square. Why? Why can we multiply by a square? Can you guys tell me why can we multiply by a square, a perfect square? Because a perfect square is always positive. A perfect square is always positive. In the GMAT world, imaginary numbers do not exist. So a perfect square is always positive. Okay, so what do we do? we actually multiply by x plus 4 whole square, and we reduce this inequality to be x plus 4 multiplied by x minus 3 to be less than 0. Once you do that, it's very similar to the prior question, and you get the range of inequality, and this inequality is negative between minus 4 and 3. Another so for those of you who made a mistake, can you tell me where did you make a mistake? For those of you who made a mistake over here, but half the class made a mistake. Why did you falter here? You multiplied it with x plus 4. Okay. Guys, if you have a question, please put the question in the Q&A pod. That way Ashutosh can take that question, and while we still go on with our session. All right, you multiplied with x plus 4. So what's the learning for you? What's the learning for you in this case if you made this mistake? When it comes to inequalities, you can only multiply with a term that's definitely positive if you don't change the sign, or without changing the sign. If you multiply with a negative number, you've got to change the sign. If you don't know, then you can't really multiply. X less than minus 4. Okay, again, if you have a question, please put the question in the Q&A pod, Rene. But the question that I'll have to ask you is, what does x less than minus 4 mean? If x less than minus 4 means that x is minus 5, try putting minus 5 in this inequality and really see what happens. Is it still negative when you put minus 5? Okay. All right. Now we're going to do our last question, last warm-up question for the day. Then we're going to go into real questions where we're going to actually have a bit more rigorous analysis than what we've been doing. Here's our last question. Here is the poll over here. And we'll share an article on wavy line method fairly soon. Right, last 10 seconds. 5, 4, 3, 2, and 1. Let me end the poll, broadcast the results. Again, about 77% of you got it right. The answer is choice C, which is minus 8. X lies between minus 8 and plus 2, both inclusive. How do you go about doing this? You actually really say, hey, let me substitute x plus 3 as z. And essentially, this absolute inequality reduces to z less than or equal to 5. So if you visualize this on a number line, you actually locate z at 0 and you go 5 units from it on either side. And essentially, this limits goes down to z is between minus 5 and plus 5, both inclusive. You replace z by x plus 3, and then you just do the math, and you get x is between minus 8 and plus 2. That's It's fairly simple. It's application of what we did in the first warm-up question over here with a couple of concepts of absolute value. Okay, so what did we learn on this? What's the basic value of basic absolute value concept, and how do you interpret absolute value as a distance between 2 points? Okay, now one of the things that's really important is we did the warm up, it was to brush the concepts. You need to make sure going forward, if you're going to solve more difficult questions, which we will, you have to make sure that you're absolutely clear with the concepts that we just learned, because these are the concepts that you need to know to solve real GMAT questions. Uh, if you made a mistake, note down why you made a mistake. uh, Revise those concepts post this session, and as we go forward, make notes of things that you stumble upon. Why? Because when it comes to GMAT Quant, it's not about the math, it's about inculcating good habits, which is something that we want to do. But the only concepts that you need are the ones that we just saw in the warm-up part. If you know those concepts, you should be able to answer the most challenging questions that the test is going to throw at you fairly easily. Now, it can get very laborious, but you should be able to answer that. And again, I'm going to share the session PDF with you towards the end of this webinar, and you'd get the link to the wavy line method. I know you can't click on it right now, but towards the end, we will share this PDF. Okay. With that, let's start with solving 600 to 700 level GMAT style questions. And the way we're going to do this, I want my first mark your answer poll over here. Here is the poll. What I want you to do is before uh, we start this, I want you to select still solving. That way, you as a group time yourself. I don't time you guys. And once 80% of you choose an option other than still solving, I know that more or less you guys have answered this question, and then I can then call time. Okay, let's get to about 60 people saying not still answered or still solving. I'm sorry. Let's get to 60%. 60 people. I only have 49 people. Yes, you don't see a question because I'm waiting for people to choose still solving. That way I know when you guys are done. 55, 56. I'm waiting for 4 more. 57, 58. Let's do one more. 59. One person has chosen choice C because he or she believes that choice C is probably the likely choice. All right. Here's your first question. Guys, 80% of the group is done. So I'm going to call time, another 10 seconds. 5, 4, 3, 2, and 1. Let me end the poll. Broadcast the results. Most of you got it right. It is choice C. Indeed. So we're going to quickly go through this just to make sure those of you who did not get this right know where they made a mistake. So what this question is asking, fairly simple question. You're given an inequality. The only thing is it's not in the standard form. You have x on both sides. The question is asking what's the range of x for this inequality. Okay. So what do you have to find? You have to find the range of x. You're given this inequality. Again, the first thing you have to really ask yourself is there a constraint on the values that x can take? And when you read the question again, there is absolutely no constraint. Always do this, because if you don't do this, you're likely to make the mistake. You're likely to make a mistake even when you do the math right. Okay. So what do? You rearrange the terms. You actually get all the terms with the x on the left, and all the other terms, numerical terms on the right, and you get to minus 32x is greater than 64. Now, the few of you who made a mistake, if you multiply minus 1 on both sides, if you don't change the sign of the inequality, you're going to get 32x is greater than minus 64, or x is greater than minus 2. That is if you don't change the sign of inequality and you make a mistake. On the other hand, in that case, what you're going to really do is you're going to be choosing choice B. But when you multiply by minus 1 on both sides, you actually have to change the sign of inequality, as you can see over here, and you get x less than minus 2. What does this mean? That x is between minus 2 and minus infinity, which leads to choice C. Again, what's the concept that's being tested? That when you change this, when you multiply an inequality by a negative number, you reverse the sign of inequality. Okay. Those of you who made a mistake, was it because of not reversing the sign of inequality? Or let's kind of figure out why you made a mistake. Why did you make a mistake? Let's kind of figure that out. The few of you who made a mistake over here. Silly mistake with a selection of choice. Okay. You didn't read the choices properly. Selected choice D. And then, as this says, this is typically a silly mistake. Okay, please write it down on a paper over here. You didn't make a mistake with the math. You made a mistake when you should have gotten the credit. You actually lost the credit. All right, not reversing the sign of inequality. Made a calculation mistake. So we've actually three different kinds of mistakes. One is people made mistakes because they didn't read the answer choices rather. The second is did not reverse the sign of inequality, and the third is made a calculation error. All right, thank you very much. When you give feedback, I think it helps everybody, because these are mistakes that some may not have made in this particular question, but they probably will make or will have made earlier in other questions. All right, guys, so you guys know the drill. Move to still solving. I'm gonna share the results. So we are with still solving. I need to see 60 responses over there. Okay. I want people to look at still solving. This is not the question. I'm going to still give the question. 49, 59, one more. Okay, we have 60. I'm going to remove broadcast results, and here is your next question. Alright guys, almost 80% of the class is done, so let's get those responses. 3, 2, and 1. Let me end the poll. I'm going to broadcast results. Now, here's something that's very interesting. It's also something which is very unfortunate. About 80% of you solved this correctly, yet only 33% of you got this correct. For those of you who chose choice A, can you tell me where did you guys make a mistake? For those of you who chose choice A. Integer, yes. Did you make a mistake with the math? No. You did not look at the constraints. What did I tell you in the last question? What is the first step you need to do? What is the first step that you need to do even before you start solving? Look for constraints. Yes, look for constraints. Read the question. Don't get into solving the question. You will get ample time. The GMAT is not a test of speed. If you read the question, if you keep your calm, then you're going to find that you get to the answer. One of the other things is not be overconfident. So when you really say the answer is -2, you're kind of being overconfident over there. So what's going on over here? You're given two inequalities and the question is asking what's the minimum value of integer x given these two inequalities that satisfies these two inequalities essentially. The first one we'd already solved last time. And again, the constraint is you've got to find the minimum value of integer x. You did the minimum value, that's why you chose -5.5. You didn't look at integers. The fact that it has to be integer. So let's kind of look at how we go about doing this. We already know the first inequality is x has to be less than -2. Let's kind of focus on the second inequality now. And to do this, we get all the terms with x on one side, all the non-variable terms on the other, and you get 2x is greater than or equal to -11. And you divide by 2 on both sides. Remember, 2 is a positive number, so we don't have to change the sign of inequality, which means x has to be greater than or equal to -5.5. Now, drawing this on the number line, which means that you go from -5.5 to all the way towards plus infinity. But because of the constraints which was imposed by this inequality, we can only go till -2. When you really say, hey, what's the smallest value that's integral that x can take, you say -5. Okay. So what did we learn from this question? What did we learn from this question? Read the question stem carefully. Always check the constraints. Now, I'm going to go to the next question. Next question is very interesting question, doesn't require a whole lot of solving. So I hope you carry on these lessons to the next question. But before I show the next question, I want you to click on still solving. That way you guys time yourself as a group. $57. Let's get three more. Three more people saying still solving before I show the next question. All right, perfect. Let me remove broadcast results. Here is your next question. Here's the next question. All right, guys, 80% of the class is done. I'll give you another 10 seconds to select your option. 5, 4, 3, 2, and 1. Let me end the poll. I'm going to broadcast the results, but I will say that what promise did we make to ourselves? What promise did we make to ourselves? Don't hurry. Yes. Read the question. What else? Look at the constraints. Okay, so we read the question, and I can see some of you have read the question. Now, for those of you who chose choice C, I'm going to focus just, this question is just for those who chose choice C. Okay. What happens to z square plus 4? In the context of this question, what happens to z square plus 4? It can't be negative, always positive. All right, why is it always positive? Because what is always positive? The z square, right? If z square is always positive, then can z square take on a negative value? When you choose minus infinity? Why did you choose choice C then? If you got that z square is always positive, then when you're really worrying about z square, isn't that a mistake that you guys made, which is frankly not a math mistake? Okay. So, the question asks, what's the range of values of z square given the product of two numbers? One is z square plus 4 and the other is z square minus 2. And what's given us is the product of these two numbers has to be negative. Now, what do we know? We already know that essentially we have to solve this inequality, and we know that z square plus 4 is always greater than 0. Why? Because in the world of GMAT, a square is always a positive number. Okay, so we know z square plus 4 is always greater than 0, which means z square minus 2 has to be negative, which means that z square has to be less than 2. Z square can't be equal to 2, which means z square is between 0 and it can take the value of 0, because when it takes 0, the entire product is still negative, but it cannot take 2. Broadcast results, but 28% of you got this right. Now, why did you or where did you make a mistake? For those of you, was this question difficult? Forgot about z square. Yes. And yes, it's a 600 level question, but if you look at the stats, actually it's a 700 level question. Okay, didn't consider z square. The second reason why you made a mistake was because you chose B instead of D. Okay, it wasn't just tricky, it's again the same thing that we talked about, which is that before you start solving, you look at is there a constraint, and sometimes constraints are implicit. They're not as explicit as was there in the first question where we focused on the non-negative integral values, but sometimes they are a bit more explicit. Okay, all right, so let's kind of do a different version of this question, and I'm going to clear the response. I'm going to give you a different version of this question, but before that, let's kind of do again still solving so that I can call time accordingly. And for the next one, again, read the question stem carefully, please. All right, I want to get to 60 again, still solving. I've gotten to 50, 53, 54, 57, 58, 59. Let's get to one more. All right, removing broadcast results, showing you the next question. Just give me 1 second, go through the animations. Here's your next question. Same, the identical inequality, different question. Guys, we're 80% done. Let's get those responses. 3, 2, and 1. Let me end the poll. Broadcast the results. Much better performance this time. 58% of you got it right. The correct answer is 2. Why? So what do we have to find? What do we have to find? What does the question ask us? How many values of z square satisfy this inequality? And what's the constraint given to us? What's the constraint given to us? That z is an integer. Okay. Now, in the last question, we said z square has to be less than 2 and it has to be greater than or equal to 0, which means the values of z square, and let me see, which are integral and that satisfy this inequality are 0. Z can be 0 and z square can be 0 and z square can also be 1. Okay. Did everyone get that? Now, for those of you who chose choice D, which is 3 values, why did you get 3 values? For those of you who chose choice D, which is 3 values, which is the third value that you focused on? Pick the values for Z, and that's why you chose -1. And that would happen if you really don't read the question. How many values of Z square are required, not Z. If there were values of Z, then -1 would have been correct. Again, read the question stem properly. Don't rush into solving the question. Again, this is the same question solved using the wavy line approach. We are gonna not worry about it. But let's kind of analyze the 4 questions. Okay, the first question, again, a very basic application of inequalities. We had 2 inequalities. The thing that we had to remember was that you've got to change the sign of inequality when you multiply it with a negative number. Okay. The third and fourth question focused on that that a perfect square is always greater than or equal to 0. Uh, In third and fourth, again, we focus on z square, and we really also said z square plus 4 is always positive, and throughout this we also focused on constraints, whether something's integral or not. So in second question, where we said positive, we really looked at what's the minimum value, and we had two inequalities, and we had to make sure that it had to be the minimum integral value. Again, the math hasn't changed from the fundamental questions that we did, or the warm-up questions that we did early on. What has changed is the way the questions are worded. There are more constraints. Some of those constraints are explicit, others are implicit, which means as we solve questions, we have to be more methodical. We have to write more things down. We have to focus on the constraints. As long as we do that, most of you know the math. All right, so now let's do a few more interesting questions. We're going to go to 700 level questions. And before I show the question, I want you to select still solving. All right, let's get to 60, 46, 48. Let's get to 60 if you're saying still solving. 51, 53, 55. Let's get to a few more. 56, 58, 59, one more. All right, perfect. Here's your next question. Good luck, guys. All right, about 70% of you are done. Another 20 seconds. Guys, get those answers in 3, 2, and 1. Broadcast the results. Let me end the poll. You guys did actually reasonably well, I would say, considering this is a 700 level question. I'd say you did pretty well. So, when you think about the concept tested on this question, no different than the concepts that we've already learned. It's just that it's a bit more laborious. So, what's given to us? What is given to us? We're given to that x and y are positive integers, and these two integers follow or satisfy these two inequalities. And then the question really says, what's the positive difference between minimum possible value of x and minimum possible value of y? Okay, the first thing that says, I'm very glad that no one chose, that only one person chose -6, which means that he focused on the positive difference. Normally I see more and more people choose -6, but then I also see that a lot of people are chosen choices B and C, which means you probably haven't looked at the minimum possible part over here. Let's kind of look at how we'd go about solving this question. So what are you given? You're given two inequalities. These two inequalities are not in standard form. Also, there are some constraints. First is, you know that x and y are both positive integers. Okay, the second is, you know you've got to find the positive difference between the minimum possible value of x and the minimum possible value of y. So whenever you get a set of inequalities like this, the first thing you've got to do is to put the inequalities in standard form. Then you solve the inequalities, and then you find what's being asked. In this case, what you're being asked is the positive difference between the minimum possible values of x and y. Okay, so the first thing you do is you really take inequality 1, put it in standard form, and an equation number 1 is the standard form of inequality 1. So this is essentially your standard form over here. Okay, then you take inequality 2, put it in standard form over here as well. Okay, then you multiply inequality 1 by 3, and as you do that, you get plus 3x, and you add it to inequality 2, which has minus 3x, and x gets cancelled, which means you get y is greater than 6. How many of you got to this point? How many of you were able to get to y is greater than 6? But based on the responses that I see, but 80% of you were able to get to this point, which is, 80% of you were on the right path, had the potential to solve this question correctly. All right, let's kind of move forward. You say if y is greater than 6, all I'm going to do is I'm going to really take this equation where y minus 6 is greater than 0, and I'm going to add this to equation number 2, which is this over here. And when I do that, my y gets cancelled and I get x to be greater than 8. Again, reverse the sign of inequality when you multiply it by a negative number. Now, if y is greater than 6, then the smallest possible value of y is 7. And if x is less than 8, then the smallest possible value of x is 1. Why? Because remember, x is a positive integer. The minimum possible value of x is 1. Why? Because x is a positive integer, and the smallest possible value of y is 7. And then you really say, what's the positive difference? That's 7 minus 1, which is 6, which makes choice E to be the correct one. Now again, most of you actually did the math pretty okay. But why did you make a mistake? What if you use a simultaneous equations approach, which is kind of what we use? Inequalities, not equations, inequalities though, remember that. Okay, you can't use a simultaneous equations approach. Why? Because in simultaneous equations, there's no change of sign. Why didn't we choose 0 as the minimum value of x? Why would you think? Can you read the question again and tell me why did we not use 0 as the minimum possible value of x? Vaishnavi, read the question again. Is 0 a positive integer? Okay, good. All right. Now, where did you make a mistake? Those of you who made a mistake, where did you make a mistake? So while solving for x and y, okay, is calculation error. All right. Does it make sense to convert both inequalities to the standard form? It just makes life easier. I mean, you won't make calculation mistakes, or you'd make fewer calculation mistakes if you do that. All right, calculation mistake is where you made a mistake. This is, again, I'd call this a math mistake, but yeah. Did anyone make a mistake in choosing the minimum possible values of x and y? Faltered in the last step. Who was that? That was Lakshmi. Did everything right. Made a mistake in choosing the minimum possible value. Yes. And that's what's going to happen as questions get more difficult. They're not going to make the math more difficult. They're going to add more constraints. They're going to really kind of make it a bit more wordy. You'd have to deduce what the question is actually asking, and which is kind of what you had to do over here. Okay, the math was the same. The math was simple here. I'm not going to go through this one. This is a fairly sophisticated one. I think this is probably something which, if you're getting that Q51 value, you're going to get that. Again, the process is very simple, but I'm not going to go through this one. We want to go to absolute value questions. So, but before we go there, again, a few things that we use consistently: converting inequalities into standard form, solving the inequalities, focusing on the constraints. Again, you see the things repeat again and again, and reading the question stem properly. What are those minimum possible values? Okay, now let's go to the last few questions in this session. Okay, the first one's going to be an absolute value question. We're not going to go to data sufficiency questions over here. And again, 600 level question. Actually, before I go here, let's go through our exercise once again. Reopen the poll. Still solving. Now I'm going to put in the timer over here. $37, $41. Let's get to 50 since you guys have been so nice. Let's get to 50 only. Not worry about getting to 60. That way we get through the questions fairly quickly. 3. Let's get to 50, guys. One more. One more. Still solving. Cool. Here you go. All right, but 80% of you are done. I'll give you another 15 seconds, guys. 5, 4, 3, 2, and 1. Let's end the poll. We're going to broadcast the results. It's very, very interesting. I mean, how I see people got to the answer. The rate at which answers are coming in for various options, people who got it right, most of them got it right very, very quickly. It kind of showed that there was a clarity on approach. Then there are a few of you who kind of changed your answers towards the end. Um, so it was very, very interesting to observe you guys solve this question. Again, this is not a difficult question, but there's lots of things going on over here. When you read the first statement, what's the first constraint you notice? What is the first constraint that you notice? Z is an integer, yes, such that absolute value of Z is greater than 6. Is less than 6, I'm sorry. Now, what is this question asking you to do? This question is asking you to answer one simple question. Is Z positive? Is Z positive? That's it. It's not asking you to figure out the value of Z. Okay, that's really important. The question is Z positive? Okay, so let's see how do we go about doing this. Okay, well, the constraint is Z is an integer and absolute value of Z is less than 6. Now, when you look at this and you say absolute value of Z is less than 6, what this means is that there are 11 possible values that Z can take, which are integral, going from -5 to 0 to +5. Does everyone understand this? That there are 11 possible values of Z? All right. Okay. Now let's kind of look at the first statement that's given to us. What does the first statement say? It says absolute value of Z minus 2 is greater than 3. And again, remember there's a greater than sign over here. All right. So then we ask ourselves, can we write it in this form? The answer to that is no. Why? Because we can write this on a number line only when the sign over here is less than 3. So we have to deal with each of these separately to really figure out. So to do this, we say, hey, let's consider Z minus 2 as t. So as we do this, we get absolute value of t is greater than 3, which means on a number line, this is how t is situated. It's located at 0 over here, and then you are looking at areas which are over here and over here, looking at where t is greater than 3 or minus t is less than minus 3. So z plus 2 is greater than 3, which means when z plus 2 is positive, z plus 2 is greater than 3, and when z plus 2 is negative, z minus 2 is negative, z minus 2 is less than minus 3. Okay, as you do the math, you're going to get z is greater than 5 or z is less than minus 1. How many of you were able to get to this? Actually, let me put in a yes no poll. How many of you were able to do this, to get to this part over here, get to these two constraints? Z is either greater than 5 or z is less than minus 1. There were 36 of you who were able to get to this. Now, let's kind of put in a short answer pod. Can z be greater than 5? Can z be greater than 5? And those of you saying no, tell me why. Why can't z be greater than 5? Because the absolute value of z has to be less than 6 or z has to be less than 6. So z can't be greater than 5. You guys are absolutely correct. So which means that the only condition that is true is this one or this one in turn, which means that all possible values of z are negative. This means that we can answer our question, is z positive, which is what the question had originally asked. Which means statement 1 is sufficient, which means about 30% of you answered this question correctly. Let's look at statement 2 again. Why statement 2 independently? Because we still have to do this. Why? Because either statement could be sufficient. Statement 2 says, hey, absolute value of z is equal to 2, which in other words means z can be plus 2 and minus 2. Now, since both these values are possible, does this give us a unique answer to the question, is z positive? The answer to that is no, it doesn't really tell us that. Hence, the correct answer is choice A, which is only statement 1 is sufficient. Statement 2 is not sufficient. So, while solving this question, where did you make a mistake? But so many of you did the math correctly. Okay, some of you made a math error, but those of you who did the math correctly, where did you make a mistake? Did you not look at the constraints that absolute value of z has to be less than 6? Okay, all right. Again, it's not a math error. It is keeping things in mind. It's writing them down. All right. Now, one of the other things that you're going to really see in a lot of questions is that many of these questions won't ask you to do that precise the exact math, but they'll focus much more on logic. And the next question that I'm going to really show you is a question that's going to focus on logic. Um, and so before you go into solving that question, read the question, understand the statements, and understand what they're really saying. Okay. The next question is going to be a 700 level question. So I would want you to be careful. At the same time, I would want you to be slow in that. Okay, because if you're slow, you're going to understand the question. You're going to be able to arrive at the correct answer. All right, let's get to 50 still solving. Next question is a really fun question. You're going to really learn a lot about it. Good. I'm going to remove broadcast results. Here is the next question. All right, guys, 80% of you are done. Get those answers in. I'm going to give you another 5 seconds. 3, 2, and 1. End the poll. Let me broadcast the results. Okay, I'm kind of afraid to say I don't think very many of you got this right. Now, let's kind of understand. I'm going to put in the short answer pod over here. Okay, absolute value of a number. If you say absolute value of a number, it is always what? What is the range of values that an absolute value of a number can take? It can be greater than or equal to 0. The answer to that is it can be equal to 0 or greater than 0, which means positive, right? So let's kind of look at this part over here. So what's this question asking? The question is asking, is B greater than A? We have to find a definitive answer whether B is greater than A. Okay. So is there a constraint on either A or B? No, there's no constraint. All right. So what's the first statement? The first statement is that absolute value of A minus B is equal to B minus A. All right. So let's kind of focus on the left hand side. When we say absolute value of x is y, then there are two possibilities that exist. One is that y is equal to 0 or y is positive. Okay. In other words, y is a non-negative number, or y is greater than or equal to 0, as you guys have already said. So because absolute value of a minus b is equal to b minus a, we can say that b minus a is greater than or equal to 0. Does everyone get this? Okay. For those of you who say no, why are you saying no? Why are you saying no? Absolute value of a number can be greater than or equal to 0. That's the very definition of what an absolute value is. Right? What's the definition of an absolute value? It's the magnitude of that entire entity. So when we say that b minus absolute value of a minus b is equal to b minus a, this left hand side, the smallest value that it can take over here is 0. The smallest value it can take is 0, or it can take a value which is greater than 0. Not a minus b, but b minus a. All right. I want you to look at this equation again. Okay. And let's swap the right and left. If, because that's all that's there. What's written over here is ABS B minus A is equal to, let's say if what was given to you was B minus A is ABS X, which is an integer X, what would you say? What would you say? Would you not say that B minus A is equal to 0, that's one possibility, or b minus a is greater than 0. Is that clear? Okay. Is that clear? There are two possibilities that exist. If I told you b minus a is equal to absolute value of x, b minus a would either be 0 in case x is 0, or b minus a would be positive in case x is non-zero. X could be negative, x could be positive, but because of the absolute around it, b minus a is positive. That's all that I'm doing over here. Remember, the stuff outside the absolute value is b minus a. So in this case, what we're really saying is b minus a is either equal to 0 or greater than 0, which means that when it is equal to 0, b is equal to a. When it's greater than 0, b is greater than a. Right? That's the only way b minus a can be greater than 0, when b is greater than a. Okay, so there are two conditions possible: b is equal to a or b is greater than a. Does this definitely tell us whether b is greater than a? Does it give us a unique value? Does it give us a unique value of whether b is greater than a? No, it doesn't. There are two possible values that are over here. Okay. Don't care whether it's integer or not. There are no constraints, remember, over here. Okay. Now let's look at statement 2. What does statement 2 say? Just in pure English. Statement 2 says that a divided by b is less than 1. Okay. A divided by b is less than 1. When a by b is less than 1, then what is the possible value what is the value which is not possible? If, and let me just make, yes, someone got it right. If a divided by b is less than 1, then a cannot be equal to b, right? Then a cannot be equal to b. A equal to b is impossible. A is either less than b or a is either greater than b. Okay, those are the two cases possible. Again, do we get a definitive answer of whether b is greater than a? Absolutely not. But when we combine both these statements, what happened, I think, but when we combine both these statements, do we get a definitive answer? Statement 1 said b either has to be greater than a or b has to be equal to a. Statement 2 said b can't be equal to a, but b can be less than or greater than. So when we combine both these statements, we get a definitive answer that b is definitely greater than a, and which is why choice C is the correct answer. Only 2 of you marked it correctly. Again, this was a pure logic-based question. You got the logic of both statements. Many of you got the logic of both statements correctly. Where you faltered was combining that logic. Now, can I explain this? Can I explain statement 2 again? When I say a by b is less than 1, so what I'm saying is that a cannot be equal to b. Why? Because when a is equal to b, then a by b, Jyotika, is equal to 1. It won't be less than 1. Regardless of whether a is negative and b is negative, or a is positive and b is positive. Does that help, Jyotika? Okay, for those of you who didn't get this, I'm going to give you the PDF. Go through it. You will get it. Trust me. I understand it's a sophisticated concept, but the PDF will tell you everything once you look at it. And trust me, when you get it, the clarity that this will bring about will help you in many more questions. So trust me with it. Go through the PDF right after the session. I'm going to give the PDF in another 5 minutes or so. All right, let's go to the last question. Again, a logic-based question, but I think an easier question. All right, 35 people. Let's get to 50 people saying still solving. The next question is fun. It's not as challenging, but it's still logic-based, which means you don't need to do the math. 3, 2, and 1. Here's the next question. The question is asking, is Z greater than 2? Alright guys, 80% of you are done, and I must say the performance is better than what it was in the last question, so I'm happier in this question. Alright, so 3, 2 and 1. Let me end the poll. Let me ask you another question. Okay, so the question's asking, is z greater than 2? That's all that this is asking. Now tell me what happens. Can z in statement 1, can z take a value of minus 5? Can z take a value of minus 5? Yes. Can z take a value of plus 5? Can z take a value of plus 5? Yes. Right? So can statement 1 be sufficient? Okay, statement 1 can't be sufficient. Alright, that's good. Now, what does statement 2 tell me? What does statement 2 tell me? That z is either 0 or z is positive. Statement 2 tells you that z is either 0 or positive. Remember, it can be greater than or equal to 0. Now, is statement 2 sufficient? No, not at all. When you combine both of these statements, can z be equal to 2? Can z be equal to 0? What happens when z is equal to 0 and you substitute that in statement 1? The answer is 4, and 4 is not greater than 4, so z can't be. Okay, let's see who has the question. Kriti says, how does statement 2 tell us that z is positive? Because it tells us z is 0 or positive. Why? Because it's z is equal to absolute value of something. An absolute value of something, as we saw in the last question, is always either 0 or positive. Okay, so we know z can't be 0 and we know z is positive. So if z is positive, then the only value that z can take is a value that is greater than, what value can z take if z is positive? A value that is greater than, no, a value that is greater than 4. Yes, who said that? Nick. Thank you, Nick. Nick is absolutely correct. Z can take a value that is greater than 4. Why? Because 4.00001 minus 2 is 2.001. Square of that is greater than 4. So what's the correct answer? Both statements combined are sufficient. Okay, this is from the previous question. Yeah, I'm going to explain statement 1 again, once again. So this is the answer. The question is, we have to find, is z greater than 2? Okay, is there a constraint on z? Absolutely not. There's nothing much given over there, so that's good. You don't have to worry about constraints. The first statement says z plus 2 whole square, absolute value of that is greater than 4. Now, since the term inside absolute value is already a perfect square, we don't care about absolute value. Why? Because perfect square is always positive. So the modulus has no impact. So what do we say? We say, hey, z plus 2 whole square, is equal to, it should say 2 square over here, not 22. It should say 2 square. I think the powers are messed up. So essentially, we can really see that there are two values of z that are possible. One is that what are the values of z that are possible here? That z is less than -4. Oh, sorry, z is greater than 4 or z is less than 0. Those are the two values that are possible that you can really see from the wavy line approach. Again, forgive me, this should say 2 square, not 22 over here, and this should say z minus 2 square, not z minus 2 and then 2. Okay, so z is less than 0 or z is greater than 4. Why would you say that? Because uh, you'll have to do that for the left hand side to be greater than 4. Okay, there are two possible values. It still doesn't tell me whether z is greater than 2. Let's go to statement 2. Statement 2 says that because z is absolute value of something, it has to be greater than or equal to 0, which means that there are two cases. One is z is positive, the second is z is equal to 0. Now, again, does it tell me that z is greater than 2? Absolutely not. So statement 2 by itself is not sufficient. Now let's combine statement 1 and statement 2. Statement 1 says z is either negative or z is greater than 4. Statement 2 says z is either 0 or z is positive. Now we combine this and we really say z has to be positive and z has to be greater than 4, which means that z has to be greater than 4, which means both conditions together are sufficient. The correct answer is choice C. All right. So one thing, hopefully, that you guys have gotten from this is, the last two questions a bit more challenging, but very logic based. But there wasn't a whole lot of math in all of this, right? There was logic, there were constraints, there were explicit constraints, and there was reading the question. But essentially, when you think about what the difficult questions that we solved, there wasn't a ton of math in this, right? We didn't do a ton of calculations. There were no lengthy equations overall. And thank you for the person who said good questions. Okay. And that's kind of the key to GMAT Quant. It's not about doing a lot of math. A lot of people who actually, a lot of Indians who prepare for GMAT Quant prepare using their books from school, their books from CAT, which essentially is the Indian equivalent of the GMAT, and they think that the questions on the GMAT would be very similar to the way they are on CAT. They're not as calculation intensive. They're much more constraint oriented overall. So here's an example of a guy who's did really well in his math in school, yet struggled to go beyond Q48, Q49, but was able to hit Q51 once he understood that he had to worry more about following the constraints, reading the question stem properly, and writing down the steps that he or she is going to go about while solving those questions. Especially this particular student faltered in data sufficiency. Once he started solving questions the right way, he's able to improve to Q451 fairly quickly. Here's another example of a student who got to a 750 and was able to get into Wharton. He's actually studying at Wharton right now. Again, this guy wasn't able to cross Q45 despite having put in a lot of effort. The same thing that helped many students helped him improve to a Q49. Focus on approach. Not worry as much about the math part of it, because the math part's really simple. Focus on writing down why he was making the mistakes, using data to figure out the sections that he needed to focus on, and doing focus practice over there. Okay. He's also admitted to Stern, Tepper, and again he's studying at Wharton, as I talked about. Here's another guy who improved from a Q30, which is the 20th percentile, to a Q45. Again, starting with the right difficulty level of is really important. Why? Because if you start with questions that are really, really difficult, you're going to find that you don't learn a whole lot. You don't progress in your learning, and which is really, really important. And again, another guy who improved from a Q38 to a Q50. Again, what helped him get to that Q50? The focus on learning the fundamentals, the focus on essentially tackling one topic at a time and tracking that improvement. Once you do that, you're going to find that acing either quant or verbal is fairly simple. Okay, what are some of the next steps that you need to do? You need to start building these good habits. You need to start taking good notes with regards to when you make a mistake. Now, we didn't focus a whole lot on shortcuts in this. Why? Because if you don't have the fundamentals, uh, you won't be able to leverage shortcuts consistently on the test. The only way you'd be able to leverage shortcuts is once you have these fundamentals in there. Okay. So how do you go about getting to that Q50, Q51 score? First of all, understand how to apply the concepts. Make sure you know how to solve an inequality. When you multiply an inequality by a negative number, you reverse the sign of inequality. Make sure you understand, hey, a perfect square is always positive. Make sure you understand the implicit and explicit constraints. Be methodical. Before solving a question, write down all the steps that you're going to take. Actively read the question statement, write down the constraints, and again, trust the test maker as to you won't get questions that will require a lot of math, and believe in your skills. Everything that you need to know as to how to go about doing this is something that's there with you. So we're going to share the PDF of yesterday's session. I know many of you have been asking. Has the link to the recording for yesterday's session overall. And again, as next steps, go through the video lessons which are there as a part of your free trial. There are a few other questions which are in this PDF. I'm going to share the PDF with you. Solve them. There are a few other questions in e-GMAT Scholaranium, which is something that you need to solve as well. With that, I want to thank everyone for joining me today. Here is the PDF of this particular session. And if you would be kind enough, it'd be helpful if you can give us some feedback over here, how you liked the webinar, what were your key takeaways from this webinar. That'd be very good. One other thing, for those of you who are aiming for high GMAT scores, if you're looking to help with creating a personalized study plan, you can always write to me at rajat@e-gmat.com. And thank you for your feedback. It was really great to have you. I love the participation in the session. And Vaishnavi, thank you for writing the takeaways. With that, I wish you all the best, and I hope to see you guys on e-GMAT.com. All right, Vimal has a question. Do scholarships work for part-time MBAs as well? Vimal, unfortunately, they don't. I mean, I have not seen a single instance of a part-time MBA getting a scholarship. And trust me, our students have negotiated. So yeah, it's just when you go for a part-time MBA, the intent over here is that you're going to be working along with it, which means that, hey, because you're making that money, you should pay for it. So yeah, but we've seen people get scholarships left and right when they go for full-time MBAs. Here's an example of a student who's as he improved from 700 to 750, he got multiple scholarships from Columbia as well as Ross, if I remember correctly. The executive MBA at Wharton and Berkeley, do they have scholarships? No, then they're very expensive. Trust me. So with executive but a couple of years ago, I went to Wharton's San Francisco campus, and we talked about executive MBA over there. And what they told me very explicitly is the executive MBA must be funded by your company unless and the only exception to that at Wharton is that if you're a part of a startup, you have a significant amount of equity where you can fund the MBA yourself. They'll take you. Otherwise, it has to be funded by your company. And B, in addition to that, the company must sign a letter saying that because you're doing an exec MBA, the company understands that you'll spend a certain amount of time working on your MBA. So again, at Wharton and Berkeley didn't have similar constraints, didn't have identical constraints, but had very similar constraints too. But Wharton was very, very specific. So no scholarships for exec MBAs. But full-time MBAs, about $400 million worth of scholarships every year. And e-GMATers get about a tenth of those. Again, if you go to our YouTube channel, you're going to see many such examples of scholarships and fellowships. Okay, guys, with that, I want to thank everyone and wish you good luck.